Hey guys, today we're talking about biconditional statements. If you haven't done the assignment on conditional statements yet, like converse, inverse, contrapositive, and conditional statements from yesterday on Desmos, you should go back and do that first. This assignment follows that, and it's called biconditional statements. So what we do is we start with a conditional statement. The one I've chosen for our example is if a shape is a triangle, then it has three sides. And before we go any further, let's talk about the truth value of that. Truth value just means, is it true? So if a shape is a triangle, then it has three sides. Yes, that is true. There's no shape that is a triangle that doesn't have three sides, so that's true. All right, now what we need to do in order to check to see if we can write a biconditional statement is we need to look at the converse and see if that's true. Remember, the conditional statement is if P, then Q. The converse is where you switch them. So it's if Q, then P, right? You just switch the hypothesis and the conclusion. So in this case, our converse is going to be if a shape has three sides, then it is a triangle, right? And let's look at the truth value of that statement too. If a shape has three sides, then it's a triangle. That's true because there are no shapes that have three sides that are not triangles, so that's true. Since the truth value of our conditional statement and our converse are the same, that means we can write a biconditional statement. So if the truth value of one of these was true and the other one was false, there is no biconditional statement that we can write. We can't do it. If the truth values were both false, then we could write a conditional statement. The truth values just have to be the same. So I wrote it here. If both the conditional statement and its converse have the same truth value, you can write a biconditional statement. And the key phrase with a biconditional statement is if and only if. So that's the phrase that we're going to be including in all of our biconditional statements is if and only if. That's like the key phrase, right? And the way we show it with symbols is we show P if and only if Q. So the arrow goes both ways, and the way we say that is P if and only if Q. So back to our example about the triangle. Remember, our original statement was if a shape is a triangle, then it has three sides. So what we're going to do is take the hypothesis. We're going to say a shape is a triangle, and then we're going to throw in if and only if. If and only if it has three sides. There's our biconditional statement. We just took the original statement, if P then Q, but we threw if and only if in it and set it up that way. That's called a biconditional statement. So the key phrase there is if and only if. All right, let's look at another one. Here's our conditional statement. If I am a linebacker, then I play football. I don't know that much about football, but I do know that a linebacker is a football position. So the truth value of this conditional statement is that it is true. Okay, and remember, conditional statement is if P, then Q. The converse is where we switch them. So if Q, then P. So the converse of our example statement here would be if I play football, then I am a linebacker. And let's look at the truth value of this statement. If I play football, then I am a linebacker. I would say that's false because you could play football but be a quarterback. Or you could play football but be the kicker. I don't really know that much about football, but I do know enough about football to say that this statement is false. So you see how our truth values are different? This truth value for the conditional statement was true, but the truth value for the converse was false. For our biconditional statement, we cannot write one for this example. You cannot write a biconditional statement if the truth values for the conditional statement and the converse are different. The reason why we were able to write a conditional statement up above is because the truth value for the conditional statement and the converse were the same. They were both true. So we were able to write our biconditional statement. Okay, feel free to watch this video again. Feel free to pause it if you need to and take notes. But this is what the Desmos activity that follows this video is about. All right, bye guys.